astronomers may be witnessing something never seen before by humans.
Astronomers have captured some of the most detailed images ever seen of the galaxies in deep space.
Space is full of surprises, and not all are as friendly as these scary but true space facts will show you. Imagine floating in a huge, silent emptiness where your screams would never be heard. It's a place where chilling and unbelievable truths unfold far beyond our cozy Earth. Could the unknown answers of the universe be even more frightening than we imagine? Let us explore the most terrifying facts about deep space. Big galaxy crashes in space. Think of a scene straight from an old-school horror movie, but this time, it's happening in space. It's not only living things that devour each other, galaxies do it too. In our universe, big galaxies often crash into and swallow up smaller ones. Research shows that these massive collisions happen roughly every 8 to 9 billion years. And guess what? Our Milky Way is on a collision course with the Andromeda galaxy. They're expected to smash together in about 4 billion years, which will likely wipe out all life in both galaxies. It's a huge cosmic event that will change the face of our night sky forever. Sound is a type of energy that moves in waves. It needs to travel through something like solids, liquids, or air, because it depends on the shaking of particles in these materials. On Earth, sound moves well through the air, which is why we can hear various noises. But in space, it's a whole different story. Space is like a giant empty room with almost nothing in it. No air, no particles. This means there's nothing for sound waves to move through, so space is completely quiet. This quietness is very different from what we experience on Earth, where the air around us helps carry sounds to our ears. Without air or another material, sound can't move, making space a silent place. Although space itself is silent, scientists have found ways to make sense of space sounds. They use a process called sonification, which turns data into sound. For instance, the radio waves picked up by spacecraft are changed into sounds we can hear. These sounds aren't natural. They're more like interpretations of the data in a way we can listen to. Stay tuned for more. We've also learned about sounds in space through something called gravitational waves. These waves are like ripples through space itself, caused by huge events like black holes merging. Scientists at places like LIGO can turn the measurements from these ripples into sounds. So, in a way, we can listen to these massive cosmic events. On the Moon, sound also doesn't work like it does here. The Moon's atmosphere is so thin that there are hardly any particles to carry sound. Astronauts walking on the Moon have to use radios in their helmets to talk because there's no other way for sound to travel there. Mars is slightly different because it has a very thin atmosphere made mostly of carbon dioxide. This thin atmosphere changes how sound moves on Mars. Sounds there are quieter and more muffled, and they don't travel as far. The speed of sound on Mars is slower too, and higher-pitched sounds fade out faster. Radio astronomy has been crucial in turning space data into sounds. Fiorella Terenzi, for example, has transformed radio waves from distant galaxies into sounds. This method helps scientists and people understand the vast and complex universe a bit better. Space probes have also picked up sounds by capturing the effects of particles or turning electromagnetic waves into audio. For example, when NASA's Juno spacecraft flew into Jupiter's magnetic field, it collected changes in electric fields that were turned into sounds. The Cassini probe did something similar with Saturn's radio emissions, which relate to Saturn's auroras. Some landers on other planets and moons have even recorded actual sounds. The Perseverance rover on Mars and the Chinese Zhurong rover have both sent back sounds from the Martian surface. The Soviet Venera 13 probe caught sounds on Venus, like the wind and the noise of the probe hitting the ground. and the European Space Agency's Huygens lander recorded sounds as it fell through the atmosphere of Titan, one of Saturn's moons. While we can't hear traditional sounds in space due to the vacuum, scientists have developed techniques to give us a sense of the universe's sounds. These techniques show that the silence of space isn't complete. Through creative methods, we can hear what's happening out there, bringing the distant and silent cosmos a bit closer to our understanding. This turns data not just into numbers, but into experiences that anyone can appreciate, revealing the dynamic, ever-evolving nature of space. But that's not all. Rogue planets are intriguing space wanderers, traveling through the cosmos without being tied to any star. Unlike the typical planets we know that circle around stars, these rogue planets move through space on their own. They vary widely in size, with some as small as Earth and others much larger than Jupiter. The study of these free-floating planets has captured the interest of astronomers around the world. Initially, when rogue planets were first spotted, they were mostly huge, akin to Jupiter. But as technology has improved, astronomers have discovered even the smaller ones, roaming solo through space. It's believed that these independent planets could outnumber those orbiting stars. Upcoming projects like the Nancy Grace Roman Space Telescope, launching in 2027, are expected to uncover possibly hundreds of these rogue planets, including those that are Earth-sized. There are a couple of ways rogue planets might come into existence. They could be thrown out of their original star systems due to gravitational tugs or collisions, which send them hurtling into space. Another possibility is that they form on their own from a swirling mix of gas and dust, much like stars do, only on a smaller scale. If they form this way, they might even have moons, despite not being part of a larger planetary system. Finding these planets is quite tricky since they don't shine with their own light or emit much heat. That's where a technique called microlensing comes in handy. This method involves observing the effects these planets have on light coming from distant stars. When a rogue planet passes in front of a star, from our perspective, it bends and boosts the star's light. This creates a noticeable effect, but it's brief, making continuous and sensitive monitoring essential. The upcoming Roman Space Telescope is set to use this microlensing technique to hunt for rogue planets across a specific area of our galaxy. This long-duration survey will likely reveal that rogue planets are more abundant in our galaxy than we currently think, which would be a significant finding. Living conditions on rogue planets would be harsh. Without a nearby star, they wouldn't have a regular source of warmth and light, making them incredibly cold, potentially covered in ice, or shrouded in thick atmospheres that trap whatever heat remains. However, some scientists believe these planets might still support life if they have internal heat sources like geothermal activity. And there's more. Studying these solitary planets also provides valuable insights into how planets form and evolve. By examining rogue planets, researchers can test theories about planetary development and survival after ejection from a solar system. These investigations help clarify the tumultuous events that can fling a planet into space and how planets might form in isolation from a star. The potential number of rogue planets is astounding. Some estimates suggest there could be billions or even trillions of these lone wanderers in our galaxy alone. This suggests that rogue planets are not rare exceptions, but likely a common result of the star and planet formation processes. To study these elusive celestial objects, advanced technology is crucial. The Roman Space Telescope, for example, will play a key role with its precise, long-term observations from space. Ground-based telescopes also contribute significantly, offering additional data and helping to confirm space-based observations. The existence of rogue planets challenges our traditional views of planetary systems. They show us that planets can thrive in various scenarios, not just orbiting around stars. These free-floating planets open a window into the varied and dynamic forces that mold our universe. As we continue to explore, the field of rogue planet study promises to expand our understanding of how planets are formed, how our galaxy is structured, and even the conditions under which life could exist in unexpected places. With every technological advance, we uncover more about these strange nomads of the galaxy, broadening our knowledge of the vast universe we inhabit. Now, let's take a closer look at the strange and surprising things that happen to your body when you're living in space. Astronauts peeling feet in space. Here's a slightly gross but fascinating fact about being in space. Your skin starts falling off, especially from your feet. In the microgravity environment of space, the calluses on your feet don't have to handle pressure from walking, so they just start peeling away. And we're not talking small flakes. These are big chunks that just drift away into the cabin. If you're a bit squeamish about things like peeling skin, then being an astronaut might be more challenging than you think. This is just one of those weird things that happens to your body when you're living in space. Jupiter is pretty massive as planets in our solar system go, but it's actually small compared to the biggest planet found out there in space. This giant is called Dennis P planet, and it's huge, about 28.5 times bigger than Jupiter. It's got so much mass that some space scientists think it might not really be a planet at all. They suggest it could be a brown dwarf star, which is kind of a mix between a star and a planet. Imagine a star at the end of its life blowing up in a huge explosion. That's a supernova. The one named Assassin 15LH is the hottest and brightest one we've ever seen. It reached a temperature of about 100 billion degrees Kelvin. Just to give you an idea, that's way, way hotter than anything we experience on Earth. In terms of brightness, it was about 570 billion times brighter than our sun, which is pretty incredible. It's like a cosmic fireworks show that outshines all others. Back when we started sending things into space, a lot of different animals, like cats and dogs, and even a chimpanzee, were sent up there to see how they do. Sadly, not all of them made it back home. These animals, along with some humans who lost their lives in space missions, are now part of the vast amount of debris that orbits our planet. It's a bit spooky to think about, but these bodies are perfectly preserved up there in the cold vacuum of space because there's no oxygen to let them decompose. White holes are theoretical celestial bodies that are thought to be the exact opposite of black holes. In a black hole, gravity is so strong that everything, even light, gets pulled in and can't escape once it passes a certain point called the event horizon. White holes, on the other hand, are believed to do the opposite by pushing out matter and light. And they don't allow anything to enter them. And that's not the end of it. This idea comes from the same set of principles that gave us black holes, general relativity, a theory proposed by Einstein. Within this framework, white holes are a sort of hypothetical solution where time seems to flow backward. This means if we could see a black hole's process in reverse, it would look like a white hole, spewing out matter instead of sucking it in. Just like black holes, white holes are thought to have mass, charge, and spin. But the main difference between them is how they interact with surrounding matter and energy. Black holes act like cosmic vacuum cleaners, pulling in anything that gets too close. In contrast, white holes are like cosmic fountains that continuously eject matter and energy, not allowing anything to cross into their space. Currently, white holes exist only in the realm of theory. We have no actual evidence that they are out there. They are predictions based on mathematical models, rather than direct observation. Some scientists speculate that if white holes are real, they might explain big cosmic questions, like the origin of the universe itself. For example, the Big Bang, the event that started our universe, is somewhat similar to what we think white holes could be like, suddenly releasing massive amounts of matter and energy. There's also a fascinating hypothesis that black holes could eventually turn into white holes. Through a process known as Hawking radiation, black holes might lose mass over time and theoretically could shrink and then bounce back as white holes. This idea, called quantum bounce, might help solve a big problem known as the black hole information paradox, which deals with the question of what happens to all the stuff that falls into a black hole. If black holes eventually turn into white holes, they might release all that swallowed information back into the universe. White holes are sometimes connected to the concept of wormholes, hypothetical shortcuts through space and time that might link distant parts of the universe, or even different universes. In this view, stuff that falls into a black hole could travel through a wormhole and pop out of a white hole somewhere else. However, white holes throw a wrench into our current understanding of physics. According to the laws of thermodynamics, the universe naturally tends towards more disorder, or entropy. White holes, which imply a sort of reversal of this process, would be a big exception to this rule. Moreover, if a white hole could somehow form, it's likely that it wouldn't last long. Any matter it ejected would probably collide with incoming material, and this mess might just collapse back into a black hole. But wait, there's more. Some researchers think phenomena like gamma-ray bursts, intense explosions observed in distant galaxies, might be linked to white holes. However, these are still just theories, lacking hard evidence. To really study and confirm the existence of white holes, we would need technology and methods that are far beyond what we currently have. In the grand scheme of things, white holes are an exciting theoretical possibility that challenges how we think about space, time, and the universe. While they're still purely speculative and haven't been observed, they push the boundaries of our imagination and might one day reshape our understanding of the cosmos and the life cycle of black holes. As science advances, perhaps we'll get closer to finding out whether these fascinating theoretical objects really exist. Black holes are super interesting. They're these incredibly dense spots in space where gravity pulls so hard that even light can't escape. But what happens if you accidentally fall into one? Well, scientists have a bunch of ideas about that, but nobody knows for sure. One idea is pretty wild. It suggests that falling into a black hole could split what happens to you into two scenarios. In one, you'd get stretched out and torn apart pretty fast, a process called spaghettification. In the other, nothing bad happens at all. It's all because time and space act really weirdly around black holes. But honestly, falling into a black hole isn't something you'd want to try. After seeing the many dangers of space travel, we'll learn about the amazing and sometimes scary things the universe can do. The Big Crunch, how the universe might end. While the Big Bang kicked off the universe with an explosive spread of matter and energy, there's a theory suggesting everything could end in the exact opposite way. This is known as the Big Crunch. In this scenario, the universe might one day stop expanding and instead begin to shrink, pulling everything back toward a dense, central point, similar to how it all started. Meanwhile, another theory called the Big Rip offers a different endgame. It proposes that the universe won't just keep expanding, but do so at such a pace that eventually everything, right down to atoms, will be forcibly ripped apart. Thinking about the universe either crunching back into a tiny space or ripping apart atom by atom is both awe-inspiring and a bit terrifying. Imagine being a galaxy, sitting quietly at the edge of the cosmos, and then suddenly you're being dragged off to an unknown destination. That's what's happening in a phenomenon we call the dark flow. This strange occurrence sees groups of galaxies being pulled towards an unseen area of space, and scientists are scratching their heads trying to figure out why. It's as if a massive, invisible hand is picking these galaxies up and moving them across the universe. The unsettling part? We have no idea what this cosmic hand is or where it's sending these galaxies. Back in 2013, a regular day in Russia turned extraordinary when a meteor exploded overhead, injuring 400 people. This event is a stark reminder that meteors can appear out of nowhere, turning a calm sky into a source of destruction without any warning. These space rocks, hurtling towards Earth at incredible speeds, can wreak havoc in moments, demonstrating that our planet isn't always as protected as we might think. The idea that, without any notice, a meteor could crash down, causing widespread damage, highlights the unpredictability and raw power of nature. Stay tuned for more. Every year, the moon edges 1.5 inches further away from Earth. This tiny shift might not seem like much, but over long periods, it has significant implications. As the moon moves away, it could lead to changes in the Earth's tides and water levels, affecting everything from marine life to global weather patterns. Furthermore, this gradual drift might slow the Earth's rotation, potentially lengthening our days. While these changes are gradual, the moon's slow departure could fundamentally alter life on Earth in ways we might only fully understand far into the future. While some scientists look at Mars as a potential new home for humans, Venus is a whole different story. The conditions on Venus are incredibly extreme and harsh. The temperature on its surface is around 500 degrees Celsius, hot enough to melt lead. The atmospheric pressure is crushing, equivalent to being 2952 feet underwater on Earth. To top it all off, Venus experiences constant acid rain. These hostile conditions make Venus an unlikely candidate for human habitation. It's a prime example of how extreme and unforgiving the conditions on other planets can be. Let's talk about the end game for our solar system. We've got lots of theories about how the universe might say goodbye, but our solar system's finale is pretty straightforward. Our sun, which is currently happily burning hydrogen, won't be able to do that forever. Eventually, it'll run out of hydrogen fuel and start to expand, turning into what's known as a red giant. This expansion will be so massive that it'll eventually swallow up all the planets close to it, including ours. It's a direct and fiery ending. Imagine needing an unimaginably high sunblock to stand any chance. With new ideas about how the universe might end, let's find out what happens if you find yourself alone and unprotected in space. Surviving space, why you need a spacesuit. Ever wondered what would happen if you just popped out into space without a spacesuit? It's a short and not so sweet experience. First off, you'd have about 15 seconds before you pass out because there's no oxygen out there. But that's not the worst part. If you forgot to exhale before leaving your spaceship, the lack of atmospheric pressure in space would cause the air left in your lungs to expand, likely causing them to burst. So, a little free advice. If you ever find yourself in space without a suit, remember to breathe out. Let's meet Kelt 9b, the scorching hot planet far beyond our solar neighborhood. This planet isn't just warm, it's sizzling at around 4,600 kelvins. To put that in perspective, that's just a tad cooler than the surface of our sun, which is about 5,800 kelvins. Why so hot? Well, it orbits super close to its star, Kelt 9, which is like living next door to a blazing furnace. The intense heat makes every day on Kelt 9b feel like the peak of summer, but magnified 1,000 times. Space is incredibly cold, nearly as cold as it can possibly get. Scientists have figured out that the average temperature out there is around minus 270 degrees Celsius, or minus 454 degrees Fahrenheit. That's only a few degrees above absolute zero, which is the lowest temperature anything can ever be, sitting at 0 Kelvin. At absolute zero, particles stop moving because there's no heat energy left. So, space is not just a bit chilly, it's almost as cold gets. Keep watching for more. Currently, when you step outside on a clear night, you can see a beautiful display of stars scattered across the sky. But imagine a time, way in the future, when you might look up and see nothing but darkness. That's what scientists are predicting. They say that in about 1 trillion years, the expanding universe will stretch out so much that those stars will fade away, leaving us with a permanently dark sky. No more stargazing, just endless night. Thinking about the vastness of space, it seems almost certain that there are other beings out there. With billions of stars, many with their own planets, how could there not be some form of life besides us? However, finding that life is a huge challenge. As the universe grows, galaxies move further and further apart. This makes the idea of traveling between them, potentially to meet our cosmic neighbors, extremely difficult without technology that can surpass the speed of light. So while the possibility of aliens is exciting, actually meeting them might forever be just out of reach. Solar superstorms, or geomagnetic storms, are intense disturbances in space weather triggered by massive solar eruptions. These events can interfere with our technological systems on Earth and pose a serious risk to our contemporary way of life. A famous example of such a storm is the Carrington event of 1859, which disrupted telegraph systems and created auroras visible as far south as Cuba and Hawaii. If a similar event were to happen today, the consequences could be severe, potentially knocking out power grids, satellites, and communication networks on a grand scale. These powerful storms originate from coronal mass ejections, huge releases of plasma and magnetic fields from the sun's outer atmosphere, or corona. When these CMEs collide with Earth, they interact with its magnetic field, leading to geomagnetic storms. These storms can generate electric currents in power lines and pipelines, causing extensive power failures and damage to electrical infrastructure. The effect on power grids can be particularly devastating, potentially damaging transformers and other crucial components beyond repair. And there's more. One of the greatest dangers of solar superstorms lies in their ability to disrupt global communication systems. Satellites that are crucial for GPS, telecommunication, and weather forecasting are at risk from the high-energy particles released during these storms. When these satellites get hit, it can lead to significant losses in communication and navigation capabilities, vital for everyday life and national security. Furthermore, these charged particles can wreak havoc on electronic devices and data centers, causing data loss and equipment failures. Another significant threat is to the internet infrastructure. The undersea fiber optic cables that connect the world rely on repeaters to amplify the signal across long distances. These repeaters are vulnerable to damage from geomagnetic storms. If a large number of them were to fail, it could disrupt internet services worldwide, leading to what some call an internet apocalypse. Such a scenario would impact a wide range of services from banking and healthcare to personal communications and transportation. The Sun follows an approximately 11-year cycle of solar activity, referred to as the solar cycle. During the solar maximum, the peak period of this cycle, the likelihood of solar superstorms increases. Observations indicate that the current cycle, solar cycle 25, might reach its peak sooner and be more intense than earlier anticipated, raising the odds of a major solar storm affecting Earth. Forecasting these solar superstorms is a complex task. Scientists rely on a mix of historical data, observations from space missions, and sophisticated models to predict solar activity. Agencies like NASA use satellites such as the Solar and Heliospheric Observatory and the Parker Solar Probe to continuously monitor the Sun. These tools help in understanding the Sun's behavior and refining predictions about solar storms. Despite these technological advances, accurately predicting when and how intensely these storms will hit remains a challenging task. To lessen the impact of solar superstorms, various protective strategies need to be implemented. Power systems can be engineered to better withstand the currents induced by these storms, involving upgraded standards for transformers and other critical infrastructure. Satellite operators can also prepare by putting their satellites into safe mode during high solar activity to reduce damage. Furthermore, developing quick response protocols can help in taking timely protective measures, like temporarily shutting down systems that are most vulnerable. International cooperation is essential in managing the risks associated with solar superstorms. Organizations like NASA and the European Space Agency are at the forefront of space weather research and forecasting. By sharing data and resources, these agencies aim to enhance our understanding of solar storms and improve strategies for prediction and mitigation. And that's not it. Exploring superconductors as a protective measure for power grids also presents a promising avenue. Superconductor technology, though still in development, could potentially offer a more resilient solution to handle the electrical surges from solar storms, enhancing our grid protection capabilities. The threat posed by solar superstorms to our modern technology and infrastructure is substantial. The potential disruptions to power grids, communications, and internet services underscore the importance of ongoing research and preparedness. By advancing our forecasting abilities and implementing effective mitigation strategies, we can safeguard our technological systems against the vast impacts of these powerful space weather events. From the dangers of space to the hidden questions of rogue planets and black holes, our adventure into space continues with even more surprising discoveries. Space travel, the most dangerous adventure. Of every 430 adventurers who have shot off into space, 18 didn't return home. That shows us how incredibly dangerous space travel can be, holding the title as the most hazardous way to get around that we've tried so far. But here's a silver lining. Space travel isn't as risky as it once was. Thanks to advancements in technology and better training for astronauts, making a trip beyond our atmosphere is gradually becoming safer. With every mission, we learn more about what it takes to keep astronauts safe, continually improving the odds of their safe return. When we look up at the night sky, we're only seeing a tiny fraction, less than 5%, of what's actually out there. The other 95% is made up of dark matter and dark energy, stuff we can't see and don't yet fully understand. This huge unseen portion doesn't interact with light like normal matter does, which means we can't detect it using standard tools. The question of dark matter and dark energy represents one of the biggest challenges in modern astronomy. As scientists delve deeper into this topic, they hope to uncover more about the universe's structure and how it works. But for now, it remains one of the biggest gaps in our understanding of the cosmos, promising to keep scientists busy for years to come. If you thought rogue planets were unsettling, consider rogue black holes, which are even more daunting. These are essentially black holes that don't belong to any star system and roam freely through space. One such black hole, similar in size to Jupiter, has been spotted in our galaxy. It's racing across the universe at a mind-blowing speed of 3 million miles per hour. While the idea of a massive, invisible object zooming through space might sound alarming, the truth is, the universe is so vast that the chances of this black hole crossing paths with Earth are extremely slim. Nonetheless, the presence of rogue black holes adds a fascinating and slightly unnerving chapter to our ongoing exploration of space, highlighting how much is still unknown about the cosmic neighborhood we call home. But wait, there's more. Quasars are among the universe's most powerful and impressive entities. These intense objects sit at the centers of many active galaxies, shining brighter and releasing more energy than almost anything else we know in space. In fact, the energy a quasar emits can surpass the combined output of all the stars in our Milky Way by over 1,000 times. This makes them not only spectacular, but also extremely important for understanding more about the universe. But what exactly makes quasars so powerful? It all starts with a supermassive black hole at the heart of a quasar. As matter falls into this black hole, it doesn't go quietly. Instead, it heats up to incredible temperatures and speeds, releasing vast amounts of energy in the process. This energy is what we see as the brilliant light of the quasar, visible even from billions of light years away. Quasars are also like cosmic lighthouses. Their light helps astronomers peer across vast distances, studying the space between galaxies and the early universe. Because they are so bright, they can illuminate the gas and dust that lie between distant galaxies, revealing more about the structure of the universe. Additionally, by analyzing the light from quasars, scientists can detect the presence of elements like hydrogen and measure how these elements have spread throughout space over billions of years. Could the silent void of space be hiding truths scarier than any horror movie? What do you think lurks in the depths of the universe waiting to be discovered? Share your thoughts in the comments, and don't forget to like and subscribe for more.